Okay, so as we have mentioned earlier that the variance of two groups for the unpaired t-test, they must be similar. So therefore, we actually calculate the pool variance for unpaired t-tests. Unlike in the paired t-test, we actually calculate the differences. So therefore, the standard error for the difference between the two means are actually given by this formula. And there's one extra things that you need to calculate in the unpaired t-test, which is the pool variance. And this is the given formula for the pool variance. So what you need is actually the total samples in each of the group 1 and group 2 of your sample, and this S is actually the sum of square where you calculate in the table later on, and we call this the pool variance, and the other of the calculation will all be similar compared to the paired t-test. So let us look at the steps that involve in calculation of the unpaired two-sample t-test. So all the steps involved are exactly the same as the paired two-sample t-test. The only extra things that we do over here is actually to calculate the pool variance and the standard error or the standard deviation. So first prepare the table, the standard table, and calculate the square of the number, the x square, and we follow with calculating the standard deviation. And the third step will be calculating the pool variance and the standard deviation. Finally, and after that, calculate the t-value, compare with the reference table, and draw your conclusion. As simple as that. Let us look at the first example. An electrical bulb company, Osram Berhad, argues that their bulbs are better than their competitors, Philips Berhad. Based on the randomized sample given over here in this table, decide whether the Osram's claim is true or not. So, the first thing we need to do over here is that ask yourself, is this a directional or question or undirectional? So is there a direction in the question over here? So let us look at the question over here. What is the claim of Osram? Osram claims that their bulbs are better than their competitors. So obviously, there is a direction because they claim that they are better. So is this a one-tail or two-tail test? It's a one-tail because it claims that they are better and therefore there is a direction. So what is the null hypothesis and the alternative hypothesis for this? The answer is the null hypothesis is mean of the first group, which is the mean of Osram, are smaller or equal to the mean of Philips. So remember that for your null hypothesis, it is always no differences, no difference. So therefore, it is always equal. In this case, because it is a one-tail test, so therefore there is a direction. So what is the direction over here? They are better. So it means that the alternative hypothesis over here is that Osram, the mean of Osram readings will be larger than Philips. So larger means that it is better. So therefore, for your null hypothesis, you can apply a direction over here, which is smaller. So therefore, it is smaller or equal with the mean of Phillips. And your alternative hypothesis is opposite direction, which is larger. So this will be your null and the alternative hypothesis. So how many sample you have for Osram? 10, and the random sample collected for Phillips are 8. So remember that in our earlier lecture, so we mentioned that for the unpaired sample t-test, both of the sample size of both group doesn't need to be the same, so they can be different. And why is this an unpaired sample t-test but not a paired sample t-test? Because Osram and Phillips, they are not related at all. So let us look at the first step, calculating the x square. So as usual, prepare a table. So prepare on this fourth column x1 square. So where you need to square all the number over here for x1, and the x2 square, the square of number from Phillips. So calculate this and sum up everything and calculate the mean. So what is the answer? These are the answer that you get. So the sum of Osram x1 is 1980. So how do you get the mean? It's 1980 divided by 10. So the sample size over here is 10 divided by 10. Therefore, you get the mean of 198. For your Philip, so the sum is 1560. So how do you get the mean? It will be 1560 divided by the sample size over here, which is 8. So 1560 divided by 8. You obtain 195. Okay, so it's quite clear and simple for this step. So we move on to the second step, calculate the standard deviation. So this is the formula of standard deviation. So S square over here that you get, it is very similar compared to the paired sample t-test. The only difference is over here. These are the x square and the x, the sum of x. So it's not the difference as in the paired two sample t-test. Let us look at the formula of the paired sample t-test over here. So this is the formula for the paired t-test. So what you get is like the formula is exactly the same. The only difference over here is that this is the differences of the two group, the paired group. So whereas for your unpaired two sample t-test, you need to calculate the standard deviation for two groups separately. So just like this. So your S1 square, your standard deviation for this is, the variance for this is, so the sum of x squared, which is this one, the sum of x1 square, 392,800. So this is what you get, minus the total sum of x. So which is 1980, and you square it, divide by the total sample size, which is 10, and divide by 10 minus 1, which is 9. So this is exactly how you calculate, and the answer is 84.44. And for the S2 square, so you do the same, but for the second group, which is for the Phillips. So the total x squared is 304,800. So, and your x2 over here is 1,560. So calculate it, and the total sample size is 8, so it divided by 8 minus 1. So that will be 7, so it's 85.71. So you calculate the standard deviation for two groups separately. Unlike for your paired, you calculate the standard deviation for the differences between the two groups. Well, let us move into the third step, which is to calculate the pool variance, in which you do not calculate the pool variance for your paired sample t-test. You only do this for your unpaired two sample t-test. So this is the formula for your pool variance, and it is quite simple. So the pool variance for when we replace the number into the formula, so N1 is 10, so there are 10 samples in your Osram group, and this S1 square, so where do you get your S1 square? That is the standard deviation that you have calculated, which is over here, 84.44. So 84.44 plus your N2, which is 8, times 85.71. That's your standard deviation for group 2, divided by, so N1 plus N2 minus 2. So what is your N1? 10. What is your N2? 8. So minus 2, because there are two groups, so you minus 2. And your pool variance is 95.63. So what is your standard deviation? So it's just the square root of your pool variance, which is 95.63. So divide by 10 and plus your pool variance divide by 8, your N2. So this is the number you get, 4.63. Okay, very simple. Just replace or bring in the number into your formula. So we move into the fourth step, calculate the t-value. So this is the formula for the t-value. It is quite simple. It is exactly the same as the paired sample t-test. So x1 minus x2 divided by your standard deviation, in which we have calculated over here, 4.63. So what is the mean of x1 and the mean of x2? So that is what you have calculated in the first step over here. The mean, x1 is 198, your x2 is 195. So bring in the number. So the t-value is 198 minus 195 divided by 4.36. The number that you get is 0.65. The fifth step, compare the number with your reference table. So now your calculated t-value is 0.65. Refer to table 7. So what are the numbers to refer to? What is the degree of freedom? The degree of freedom are the sum of the sample size minus 2. So that is equal to 16. And the alpha is 0.05. It is a directional, so therefore it will remain the same as 0.05. So you do not need to divide it by 2. So refer to table 7. So 16, remember, and 0.05. So this is what you get, 1.746. Go back, and is this the number? Yes, 1.746. And now we can do our conclusion. So remember, your calculated t-value is 0.65, whereas the reference t-value is 1.746. Draw your normal curve, whereas your 1.746 is over here, whereas the calculated t-value is over here, smaller than the reference t-value. Therefore, can you reject the null hypothesis? No, you can't, because it's falling onto this area rather than here. So therefore, you fail to reject the null hypothesis. The conclusion is, it is not true that the bulbs produced by Osram Berhard are better than those produced by Philips Berhard. So that's how you actually calculate and conduct the unpaired two-sample t-test. Okay, let us look at another example. So example 2. A nutritionist wants to test if there is a difference in the mean diastolic blood pressure (DBP) values between vegetarians and non-vegetarians at p level of 0.05. The samples were selected randomly and the DBP levels were recorded as follows. So for non-vegetarians, the DBP value that you have collected, there are 8 of them. So your sample size for non-vegetarians are 8. For vegetarians, there are 9 readings collected. So therefore the sample size are 9. So for this example, is it a directional questions or is it a non-directional? Is there a direction that you can see over here? So the answer is there is no direction, because the question over here asks you if there is a difference in mean. So it doesn't mention whether it's larger or smaller. It only asks you whether if there is a difference. So it can be larger or it can be smaller. Therefore, there's no direction for this. So when there is no direction, is it a one tail or two tails test? It will be a two tails test. So what is the null hypothesis? So the null hypothesis over here, because it is a non-directional, the null hypothesis will always be equal. It will be the same. There's no difference. So the DBP value of non-vegetarians will be the same as the DBP of vegetarians. So there is no difference for your null hypothesis. So whereas for your alternative hypothesis, because this is a non-directional, so the DBP value of non-vegetarian will not be the same as the DBP level of vegetarians. So it's not the same, not equal. So there's no direction. So these will be your null hypothesis and the alternative hypothesis. Let's move into the calculation, the 6 steps calculation. What is the first step? Calculate the x square. So always prepare a table so you can do this in your on a paper, or using a calculator, or using an Excel to help you to do the calculation. So prepare the table and calculate the x1 square and the x2 square. Okay, so the number is simple. 69 square, you get 4,761. Whereas for 84 square 2, you get 7,056. calculate all the sum and the mean. So how do you get the mean of this one? So it is the sum, which is 630 divided by how many? What is the sample size here? 8. Okay, so therefore you get 78.8. Whereas for the mean of square 2 for x2, it will be 728 divided by 9. So you get 80.9. The numbers that you need to use are this one, and these two for the calculation later on. Let's move into the second step, which is the calculation of the standard deviation. So remember that this is an unpaired two-sample t-test, so therefore you need to calculate the standard deviation separately for each group. So bring all the formula in, it is quite simple. So for S1 square, so what you obtain is the sum of x1 square, so which is here, this one, 5, 50, so this is what you get, 51,100, okay? So minus the sum of x, which is 630 square. So divided by 8, because that is the sample size, and divided by 8 minus 1. So the number that you obtain is 212.5. Do the same for your S2 square. So replace it. So this is the x2 square that you obtained from the table just now. So 59,250 minus off with the sum of x2, so which is 728, square it, divided by the total sample size, which is 9, divided by 9 minus 1. You obtain 45.4. Let's move into the third step, calculating the pool variance. So this is the formula for the pool variance. It's quite simple. What you need to obtain are the standard deviation, where you have already obtained over here. S1 square is actually 212.5. Your S2 square is 45.4. So bring it into your formula. So sample size 8 for your group 1, 9 for your group 2, divided by 8 plus 9 minus 2, because there are two groups. So the pool variance are 131.8. So what is the standard deviation? So it's simply just the pool variance of divide by the sample size of each group, sum them up and get the square root of it. So this is what you get, and the answer is 5.58. The fourth step, calculate the t-value. So the mean of x1 and the mean of x2 divided by the standard deviation, which is 5.58 that you have obtained over here. So still remember what is the mean of x1 and the mean of x2. So if you can't remember, go back to the table. So the mean of x1, the non-vegetarian, 78.8. The vegetarian, 80.9. So replace them, bring them into the formula, and you get the answer. The calculated t-value is minus 0.3763. So now compare with the reference table. So what is the degree of freedom? Degree of freedom is 8 plus 9 minus 2. Then you obtain 15. So what is the alpha level over here? The significant level, because this is a two-tailed test, therefore you need to divide 0.05 by 2. So you need to refer to 0.025 in table 7. So 15, 0.025. 15, 0.025. 2.131. So this is what you get. So because this number is a negative, so your t value over here should be -2. Okay? So what is the conclusion? So the conclusion is that, so this is how it looks like when you draw your normal curve. So where is your, it's a two tails, remember? So two tails, 2.131 over here and minus 2.131. So anything fall under the shaded area, it will be rejecting the null hypothesis. But or else when it is falling in between over here, it will be fail to reject the null hypothesis. Therefore, for this case, you fail to reject the null hypothesis. The conclusion is there is no significant difference in the mean DBP between vegetarians and the non-vegetarians. Okay, so that's all for the t-test. So you may repeat this several times. I will also actually upload an online exercise in Spectrum so that you can test your own understanding. Okay, so that's all. Thank you.